we're going to look at two types of functions here. We've got even and odd functions. Now, depending on which one they are, if a function is even or odd, they have a certain type of symmetry. So if a function does end up being an even function, it's going to have symmetry with respect to the y-axis. So that's sort of shown down below there. So this is your y-axis. So if you guys sort of remember back to geometry and you talked about reflections and those sorts of things, based off that y-axis, your function is a mirror image on both sides of that y-axis. So what happens with these functions is that when you replace whatever the x value is currently in the function with a negative x value, once you've plugged that in, the function will actually end up coming out as what the original function started as. So that's what that's saying there. F of negative x, when you plug in a negative value, you get the original function back out. It actually starts, or it ends up being exactly how it started. And then the second type of symmetry is respect to the origin. And what's going to happen there is when you plug in a negative x for whatever x value is currently in there, what will happen is you'll have the original function, but you'll be able to factor out a negative sign. That's sort of how I think of it as. So when you plug in that negative x, if you can factor out a negative value from every term and end up with your original function, then you have a function that's symmetric with respect to the origin. And it shows you a picture there. So I always think you guys can sort of turn it 180 degrees is the way I look at it, but it does show you an image down there of what one might look like. So it's sort of symmetrical diagonally in both directions. But again, you can turn it 180 degrees. And it does give you the x and y values there. So you can see when you plug in negative x, you'll have a positive x, but the y's are the same. Here, when you plug in a negative x for a positive x, the y values are opposite for your second one. So it asks us to determine if the function is even or odd down below there. So all we do is replace every x value with a negative x. We're finding what f of negative x is equal to. So let's do number 7. So everywhere I see an x, I'm going to plug in a negative x value. So I will now have negative x cubed minus 7 times negative x. So this goes back to when we looked at Descartes' rule, and we looked at it somewhere else too. I can't remember where, but when you have that odd number of negatives, that's when your sign stays negative, and you can just plug in a simple value such as -1 to try it out, but -1 times -1 times -1 is going to leave you with -1. Again, we don't care what the value is, but we know it's going to be negative. And then -7 times -x is positive 7x. So I've plugged in the negative value. If it were even, we would end up with the same exact function. And we don't end up with the same function that we started with. We have a negative x cubed and a positive 7x. So what I then do is divide my negative sign out from everything, and I end up with x cubed positive minus 7x. And that is the negative version, essentially, of your original function. And you guys can always graph it to double check, too. So I did try to take a screenshot there of the function and what it looks like, so you can sort of see your axes here. And you can tell also that it's symmetrical to the origin. So not only does it equal the negative version of our original function, but you can also see it by graphing. So that's a good way to check if you have a calculator. So this function would be odd. So number 8, you've got g of x equals 6 over x plus 1. So the same thing. We're going to plug in negative x and see what we end up with. but you're not always going to be able to just plug it into the calculator and check, but it is a good way to verify. So 6 over negative x plus 1. So when we pull out or factor out a negative, what this really is negative 1, which is the same as negative 1 over 1. We're not going to do negative 1 over negative 1, because a negative over negative is a positive, and then we aren't factoring out a negative at all. So all that really happens here is we factor out a negative from the top value. So we're going to make that negative 6, and the bottom will just stay. You could also do it vice versa. You could keep the top the same and factor out a negative in the bottom. But either way, neither way is going to give you a function that is the same as what you originally started with. So this is not symmetrical at all. So it's not going to be even or odd. And again, we can always graph it to check it. So give me a second. So again, your graph, and I know it's sort of hard to see, your axes are right here because I zoomed in on my graph. So your function is symmetrical to its asymptotes, but not to the actual origin of 0, 0. So for number 9, again, plug in negative x. So f of negative x. And so negative x to the 6th plus 3 negative x to the 4th minus 2 times negative x squared minus 7. So when we plug this negative x in, remember, only the ones with the odd values or odd exponents are going to keep that negative value. So this actually becomes positive x to the 6th, but that negative is still out in front there. Plus 3 positive x to the 4th minus 2 times positive x squared minus 7. So what we have here is our original function. Negative x to the 6th plus 3x to the 4th minus 2x squared minus 7. And again, you could graph it and check, is it symmetrical to the y-axis? But it will be, so this function is going to be even. So let's look at the last one, number 10. And just for space, I'm going to sort of do number 10 below. So let's see, f of negative x equals negative 5 times negative x over 12 minus negative x squared minus negative x to the 4th. So the top becomes positive 5x. X squared and x to the 4th are going to become positive, so we have 12 minus x squared minus x to the 4th. So again, I always like to just try to pull a negative out in front here. Negative 1 is what you're really dividing by. So if we factor out a negative 1, the top will become negative 5x, and the bottom stays. We don't have a negative over negative because that would really be a positive value. So 12 minus x squared minus x to the 4th stays when we factor out that negative. So what we have here, when we factor that negative, we end up back with the original function. So this one would be even.